Hi friends, welcome back. We're talking today about graphing rational functions and oblique asymptotes. Oblique just means a slanted bit. It's not horizontal, not vertical, it's just a slanted line. Okay, so in the previous videos you've learned everything you need to know about graphing as far as these guys right here. You want to factor it, then you find your holes, your vertical asymptote, your horizontal asymptote, your intercepts. Now, where this oblique falls into place is when you're looking at your horizontal asymptotes. If you have no horizontal asymptote, then if you have none, check for oblique. So none, check for oblique. I should probably write that in there. That makes it a little more helpful. Okay, so the first thing we want to do is factor this guy. And if we do that, we get f of x equals x plus 5, x minus 12. That will give us 7, and together will give us 60 over x plus 3. So we have no holes here. Okay, so you always just want to do that just to check to see if you have holes. Now, if you compare these, you'll see that compare our exponents, it's bigger on top. Bigger on top means none, right? That's where you check for oblique. And here's how you check for an oblique asymptote. You just do long division for these guys. So I say x plus 3 and divide that into x squared minus 7x minus 60. Okay, so here's what we do. We look at this and we say, how many times, or what do I need to multiply x by to get x squared? Well, I just need to multiply it by x. Notice I'm lining it up in my x column. You want to be very clear about this. Take this x, multiply it, and distribute it to those two things. We get x squared plus 3x. Now we're going to subtract, and subtracting can be a little wonky. All you're doing is changing signs. So instead of saying subtract, I just say change your signs. So we're going to change our signs. So here what we have is these guys go away, and we have negative 10x. When we change our signs, we also bring down. Now we look at this. What do I need to multiply x by to get negative 10x? Just negative 10. Negative 10 times these two things will give me negative 10x minus 30. Change our signs. We get negative 30 is our remainder. So technically we would write it like this. But when we're talking about oblique asymptotes, I don't even care what the remainder is. This is the information that you want. So your asymptote is oblique asymptote is going to be y equals x minus 10. Y equals x minus 10. And so what does that look like? Well, if we take a look at a graph, right, it's just a normal graph. Y equals x minus 10. We start at negative 10. So we go 2, 4, 6, 8, 10, all the way down here. Sorry, that was a little long. And then our slope is 1. So we rise up 1, run over 1, up 1, over 1, just like this. And so this would be, and you just keep going across, this would be our, if we were completely graphing this, this would be our oblique asymptote. So let's take a look at what that looks like on Desmos. Remember, when you go out to Desmos, just hit the graphing calculator button right in the center. You'll get this, and then you just type your information in. So I've typed that in for us here. And sure enough, if you see, we started at negative 10. Remember, there was that line going through negative 10, and then it was going up like this, just up 1 over 1, up 1 over 1. And if I zoom way out on this, you can see, yep, that's exactly what's happening here. We've got a line going just along here, and all of those things are, and those two graphs are lining nice up with that. So let's try another one of these. All right. So we're not talking about like finding your intercepts or your asymptotes, that kind of thing. Okay, so let's take a look at this guy. Again, when we want to find our oblique asymptote, we go here. And so we want to factor this one first. It looks like I can't really factor anything out of there though. So I could factor an x out, but that's not going to help me. So we can just leave it the way it is. So we look at this, we see it's bigger on top, which means there is no horizontal asymptote, but we need to check for an oblique. And we do that by x minus 3 divided by, now in this case we have 3x to the second minus 7x, and I want to put in a constant because you always want to double check that you have a placeholder for everything. So if this was x to the third and x to the second was missing, you'd put 0 times x to the second because we're allowed to multiply anything by 0. So I've put in a placeholder. You want to do that for your constant as well. What do I need to multiply x by to get 3x squared? Just 3x. Now take that 3x and multiply it through this binomial here, and we get 3x squared minus 9x. Change our signs. We get 2x and plus 0. What do I need to multiply x by to get 2x? Just 2. 2, and I'm going to take that 2 and multiply it through this binomial here. So we get 2x minus 3. Change our signs. We get positive 3 as the remainder. Remember, I don't care what the remainder is. All I am worried about is this thing right here. So our asymptote is y equals 3x plus 2, meaning our y-intercept is at 2, and then we're going to rise up 3 and run over 1. So let's take a look at what that looks like on Desmos. All right, sure enough, there's another one up here, but I'm just going to show you this down one here. Sure enough, if we go to 3 here, at 2, our y-intercept is at 2. Words are hard. Y-intercept's at 2, and then we rise up 3. So 2, so right up to here, and run over 1. So we have a line that's going right down here, and sure enough, you can see that line is right along into here. I want to pick up my ruler and show, but it's on the screen. You wouldn't be able to see that. So, but you can see that it goes like right along here. So when you're asked to find an oblique asymptote, you just graph that line. Okay, let's try another one. Let's see, we've got this guy right here. And it says to graph these, but we're just talking about finding the oblique asymptote for now, and then you can apply all the rest of your rules of graphing to these. Okay, so we look at this and we see that on our horizontal asymptotes, it's bigger on top, so that means that we don't have one, but we need to check for an oblique, and we're going to do that by dividing. This one does not need any sort of placeholder because it goes x squared, x, and then our constant. So if we've got this, what do I need to multiply x by to get 2x squared? Just 2x. Take that 2x and multiply it to this binomial. We get 2x squared plus 2x. Change our signs. We get 5x. What do I need to multiply x by to get negative 5x? Just negative 5. Take that negative 5 and multiply it into this binomial. We get, oh, whoops, I'm sorry. I forgot to bring down. Whoops, there we go. Now take this and multiply it into here. Negative 5x minus 5. Change our signs. We end up with negative 4, so minus 4 over x plus 1. But again, we don't care about that. We just care about this guy. So let's take a look at what that looks like on a graph. So if we have our graph here, it's 2x minus 5. So this is the one I use for 10. So 2, 4, and 5. So it's y equals 2x minus 5. And then we rise up 2 and run over 1. Up 2 over 1, up 2 over 1, up 2 over 1. Just as a reminder on how to graph linear functions, aka just graphing lines. Okay, so you can see that that's where our asymptote is. And if you look on Desmos, you can see, here we go, right there. And sure enough, that's our asymptote going right along that line right through there. So hopefully this helps clear that up. If you have any questions, let your teacher know. Otherwise, we will see you next time.